Hi all, I'm Sebastian Porav and I'm working in Robin Bond Group and Steve Munch. And today I will talk to you about my experience with HexAuFoil, also on membrane protein, but slightly bigger, maybe like 7 times. It's around 400 kilodaltons. So I'm working on TRIP ion channels, which are part of TRIP superfamily of ion channels, and they have 6 transmembrane domains for 1 monomer. And to form a functional channel, they need to assemble in tetramers, which can be homo or heterotetramers. But I will not talk a lot about my protein. I will talk about more about HexAuFoil. And I have no idea why it's doing that. Yeah, so first you need to be sure that your facility has the proper setup for it. You need, for a good data collection, I think you need fringe-free and AFIS. Our facility has 2 cryoses with selectors and Falcon 4i. I think you can collect without AFIS, but I would prefer to have AFIS if I would have to choose quantifoil, to choose HexAuFoil. This is becoming annoying. So in terms of grid optimization, we played quite a lot with glow discharging for the grids, but in the end we decided to use the same settings as for UltrAuFoil. I usually glow discharge them for 90 seconds, and immediately after I glow discharge them again for 30 seconds. I use Easy Glow. We can also use a plasma cleaner. I think I only used it once. I didn't see any difference between the 2 types of glow discharging, so I like simple things. I stick with the Easy Glow. In terms of blotting, we use the VitroBot. The blotting condition changes between samples, type of paper that you're using, and also how well calibrated is your VitroBot. We had problems after servicing. We had to adjust the conditions. Something changed. In our experience, to have good results with HexAuFoil, we need to blot for at least 10 to 15 seconds. We didn't have any luck with 3 seconds or 5 seconds. We had very, very thick ice. I have no idea why, seeing your presentation now. And in terms of blotting force, we didn't see any major impact in terms of ice quality, regardless of the force. From 0 to 6, it was basically the same. They looked identically. In terms of protein concentration, we didn't have any problems using 1 milligram per milliliter, the same concentration that I usually use for any other type of grids. In terms of grid screening, I think it's very important to be in eucentric height and do your image shift calibration properly. Take your time and test it again and again, and you need to be very accurate with it. If not, you will fail your data collection in case you are also collecting data. In terms of magnifications to use for Atlas, it's anything that gives you a good stitching and a good coverage of the grid. For grid square, you would hopefully have only 1 hexagon in there. If not, when you're selecting your holes, you will see that it fails. It will also go to the next grid square, and it doesn't like it. I have no idea why. In terms of magnification for whole eucentric, usually you want one hole per image. This is for normal grids, but for HexAuFoil, we found that it works better when you have multiple holes in there, and that is not causing any problems with setting up the data collection or screening. And in terms of data acquisition, I would say go for as high magnification as you can, as your microscope is calibrated. If you have any gold in the image, that actually doesn't cause any problem with data processing further. This was one of the grids that I used and collected data and got a 2.3 angstroms resolution of trip channel. What I wanted to show you here is that even in the hole, in the hexagons where you can clearly see the shape, you actually have eyes. Compared with when you're looking for a square on normal grids, you don't want to see the edges. You don't want to see a perfect square because that usually means that you don't have eyes. It's not the case here. Not in case of the HexAuFoil. That's actually very thin eyes, and where you cannot see the square, the hexagon, where you cannot see the shape, that actually means that the ice is very thick in there. It's very uniform ice inside the square, but or the hexagon, but you have usually you have a gradient around the grid. And the sharper the hexagon is, the thinner is the ice. I think I collected around 7, 8 data sets on HexAuFoil. At the moment, I couldn't find any hexagon where I had empty holes, regardless of how thin the ice looked. I actually got proteins out of it. In terms of screening, play with the defocus to actually see if you have the protein in there, because the ice looks slightly different compared with normal grids, and it's very easy to say that you don't have ice in there. But if you're playing with the defocus, you can actually start to see some, hopefully, your protein in there, if not contaminants. And don't forget that you are using a different magnification. Your protein will look way bigger, and it's difficult to spot which one is your protein and what's actually noise or contaminants in there. Yep. As I said, the ice is very uniform inside of the hexagons, and you have around 5,000 to 6,000 holes. So that means 5,000 or 6,000 images. You don't need a lot of hexagons to get a decent data. So in my case, I only needed two hexagons to get 2.3 angstrom resolution. In terms of data collection, if you are screening multiple grids and you are putting the one grid back, do the atlas again and redo the image shift calibration, because even if you did it perfectly at the beginning, it will change a little bit when you're putting the grid back, and that will mess up your data collection. I usually use CryoSpark for my data processing, and this is my normal workflow. It's nothing special, and it's combining blob picking and template picking. And I just wanted to show you that it works very nicely in both cases. It picks particle, it identifies and picks the correct particles, and also it's very easy to remove the picks on the gold. And an interesting feature that I found with this grids is that after using the inspect particles, it has like a wedge where it's not peaking, very close to the hole. So around, usually you have peaks everywhere. In case of HexAuFoil, it's not peaking around the hole. I have no idea why, but I think that works quite well. And it's same for template peaking. They work quite well, and as you can see, I got very nice 2D classes with a lot of secondary structure in there. And I actually compared the HexAuFoil with the UltrAuFoil. This is the same protein, the same prep, the same data collection, like the same session of the microscope. Two different days, one after another. And in terms of HexAuFoil, I only needed two hexagons to get a structure. Got around 12,000 micrographs, and on UltrAuFoil 11, so pretty much the same amount of micrographs. The only difference between them is the processing time, which in case of HexAuFoil, because you have a very small pixel size, you have big boxes, and that slows down the processing quite a lot. But as long as you don't hit the exquisite, you can process it binned, and it's not affecting the resolution. Actually, this resolution is with the particles binned twice. Running a processing and refinement with the full box size, it didn't affect the resolution or the quality of the map. An interesting thing is how stable the collection is in terms of defocus and the CTF fit compared with the UltrAuFoil. They were quite stable. And in both cases, I got very nice, nice structures, very nice 2D classes between them. And the only difference with HexAuFoil, I needed way less particles. I had around 90,000 particles for this structure at 2.3. While with UltrAuFoil, I got slightly worse resolution, 2.5, with 190,000 particles from the same amount of micrographs. And some conclusions: it's a very uniform ice inside one hexagon, and also in the hole. Because they are so small, you don't have a gradient. Even when you're using detergent in your sample, I couldn't see a gradient around the hole. With normal grids, the UltrAuFoil or the carbon one, 1.2, 1.3, sometimes you start to see a gradient where the ice is thicker in the middle, on the sides. It wasn't the case with HexAuFoil. They're slightly, I have no idea why it's doing that. They're slightly more annoying to set up the data collection, and they are time consuming, but you don't need a lot of hexagons, so you only need to do 1, 2, or maybe 3 hexagons in case you don't have a very challenging protein. And in terms of processing, everything works as normal. You don't need to do any tweaks with it. At least in my case, I didn't need to do anything special. And I want to thank my colleagues and supervisors.
Very good, sir.
Thank you very much.